Welcome back, recruits, to Phase 5, Part 2 of AP Calculus Bootcamp. You are now authorized for Operation Deep Analytics. We are moving beyond the first derivative to master concavity, synthesis of data streams, and applied optimization contexts. This covers topics 5.6 through 5.12. Let's begin. Here is your mission briefing. In Part 1, you gathered intel using the first derivative, f prime, to identify critical points and dictate whether the function's trajectory was increasing or decreasing. Now we expand our arsenal. You will utilize new intel from the second derivative, f double prime, to map terrain curvature, synthesize multiple data streams, and execute real-world physical objectives. We initiate our tactical terrain scan by defining concavity. The second derivative reveals the curvature of the original function's terrain by telling us if the first derivative is increasing or decreasing. If f double prime is greater than 0, f prime is increasing, meaning the terrain is concave up, like a satellite dish catching a signal. If f double prime is less than 0, f prime is decreasing, and the terrain is concave down, like a radar dome. Your next target identification protocol is locating points of inflection. An inflection point is a structural shift where the graph of f officially changes its concavity. The trigger condition occurs only where f double prime equals 0 or is undefined, and f double prime officially changes sign. Warning: just because f double prime does equal 0 does not guarantee an inflection point. The terrain must flip its concavity to confirm the inflection point is real and not a decoy. Once a critical point is locked where f prime equals 0, you can verify the target using the second derivative test. This is an alternative to the first derivative test. By evaluating the curvature with f double prime at that exact coordinate, you get instant confirmation. If f double prime is positive, the terrain is concave up, confirming your target is at the bottom of a valley, a relative minimum. If f double prime is negative, the terrain is concave down, confirming your target is at the peak of a hill, a relative maximum. So which test do you deploy for your loadout? The first derivative test relies on a sign chart radar sweep, requiring you to test intervals around the critical point. It is best used when you have a visual graph of f prime of x. The second derivative test plugs the critical point directly into the f double prime equation. It is highly efficient for simple polynomials, or when you are given specific data points in a table instead of a full equation. Both weapons neutralize the same target. Choose based on available intel. To master free response questions, you must memorize the Intel Translation Rosetta Stone. These data streams are permanently linked. If f double prime is positive, f prime is increasing, and f is concave up. If f double prime has a sign change, f prime has a local extremum, and f has a point of inflection. Classified directive: never conflate the traits of a derivative graph with the original function. An f prime graph going up does not mean f is going up, it means f is concave up. Let's look at the signal alignment on the monitors to visualize this connection. Look at the vertical alignment. F changes concavity at the exact same coordinate where f prime hits a relative extremum, which is the exact same coordinate where f double prime crosses the x-axis. A successful agent seamlessly translates between these graphical representations. We now move to special operations, applied optimization contexts. Optimization strips away abstract numbers and applies absolute extrema protocols to physical realities, maximizing volume, minimizing cost, or calculating optimal distances. Key insight: the calculus doesn't change, only the stakes do. A physical boundary, like a limited length of material, simply becomes your closed interval. Here is your execution protocol standard operating procedure for optimization. Step 1. Map the terrain by identifying your primary equation and secondary constraints. Step 2. Consolidate intel by substituting the constraint so your primary equation relies on only one variable. Step 3. Scan for targets by taking the derivative and finding the critical points. Step 4. Verify the objective by using the candidates test or a derivative test to definitively justify your absolute max or min. Be on alert for stealth targets involving implicit relations. When functions are implicitly defined, mixing x and y, finding critical points requires analyzing the dy dx fraction. Horizontal tangents occur where the numerator dy equals 0. Vertical tangents occur where the denominator dx is equal to 0. Warning: when calculating second derivatives of implicit relations, you must substitute your original dy dx equation back into your final answer to secure full points. Review these rules of engagement for AP exam justifications. Sound reasoning must be accompanied by flawless communication. Directive 1. The no pronoun rule. Reject ambiguous targets like It is increasing. And clearly identify f, f prime or f double prime by name. Directive 2. Calculus-based logic. Do not use informal reasoning like the graph goes up. Explicitly state f prime of x is greater than 0. Directive 3. Use the given intel. If given a graph of f prime of x, argue directly from it rather than inventing an f double prime graph in your mind. Time for the after-action report. Let's debrief Phase 5, Part 2. 1. Concavity dictates the curvature of the terrain, and a sign change in f double prime confirms an inflection point. 2. The second derivative test evaluates f double prime at a critical point to instantly confirm a max or min. 3. The Rosetta Stone never fails. The sign of f double prime links to the direction of f prime, which links to the concavity of f. 4. Optimization uses these exact same calculus tools, bounded by real-world physical constraints. Unit 5 loadout is complete. Prepare for integration protocols. Status: dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.